Girls, now we're going to look at expressions today that have a proportional sign in them. Now, as I said, I don't have the worksheet, the handout I gave you, so I'm sort of trying to get things that could be relevant to this. I'm going way back here. I'm going to two questions, but they're very straightforward and they do express exactly, what we need, what this is about. So I'm going to put these two questions up on Schoology so that you can read them. But have a look at the first one. Now this is, it's linked to proportionality. So the first one says a car is freewheeling on a straight road and it experiences a retardation which is proportional to the square of its speed. So here your starting equation is a little bit different. Right, so what we're going to say is that the retardation, so if it's a retardation, it's minus a anyway for a start. If it's proportional to the square of its speed, it's proportional to v squared. Now, its speed is reduced from 20 to 10 in a distance of 100 metres. So speed goes from 20 to 10 in a distance of 100 metres. Your job is to calculate the time to travel 100 metres. Okay. So let's see how long it takes to travel, how long it takes to travel 100 metres. So this limit here is t. Now, you can't work with a proportionality sign. You have to get rid of it, which means you change that proportional sign to an equal sign, and you put in a constant of proportionality. So this becomes minus a is equal to kv squared. Now, I can work with that equation. In order for me to find t, to find time, I'm going to probably have to change this a to dv dt. But even if I was to do that now straight away, I would still have this constant that I don't know about in there. So your first job is to find the unknown. So you've got to find this unknown constant k. And once you do that, then you can go back to the original problem, which is to find a time. So you're going to use what you know. You know about v and s. So use v and s to give you k, to solve for k. Okay, so let's have a look at that then. I'm going to therefore change this a. If I've got to use v and s here, I'm going to change this a to v dv ds. So this will become minus v dv ds is equal to kv squared. Separate the variables, and this becomes minus 1 over v dv is equal to k times ds. Now I'm going to integrate both sides. I'm going to put in limits. My v limits are 20 to 10, and my s limits are 0 to 100. So when I integrate this fella here, this becomes minus 1 over v integrated is ln v, and this becomes k times s. And of course I'm putting in 20 to 10, and I'm putting in 0 to 100. So when I do this, look what happens. This becomes minus the ln of 20 minus, I've put this minus here outside, so the ln of 20 minus the ln of 10 is equal to k times a constant. I'll put in for s to 0 minus 100, putting in my limits. Now remember, this becomes, because there's two logs minus or subtracted from each other, becomes ln of 20 over ln of t, and this, when I sort this out, becomes minus k times 100. So this therefore would be minus the ln of 2 equals minus 100 times k. So that tells me that k is equal to the ln of 2. Right, so now I have a solution for k. So I'm now going to go back to the problem, which is to find t. Right, so we now have k. We know that the ln of we know that k is equal to the ln of 2. So our initial problem was, remember, to find t. So this is, I'm going back to the original equation now. Minus a is equal to kv squared. I know what k is. This is minus a is equal to the ln of 2 by v squared. Now I'm going to change this, because I'm looking for time this time, I'm going to change this to minus dv dt is equal to the ln of 2v squared. I'm going to separate the variables. This will become minus 1 over v squared dv is equal to the ln of 2 dt. Okay, I'm going to integrate now both sides. The ln of 2 is a constant. I'm going to integrate the v's from 20 using limits of 20 to 10, and of course my t is going from time 0 to time t. I'll just change this to minus v to the minus 2 dv is equal to the ln of 2 dt. Okay, so they're my integrals. So this will become minus 1 over v equals the ln of 2 by t, and of course those limits are 20 to 10 and from 0 to t. So this of course will become plus, so this now will be 1 over v is equal to ln of 2 times t. Put in the limits, 1 over 20 minus 1 over 10 is equal to the ln of 2 from 0 to minus t. This will give me minus 1 over 20 when I subtract those two, equals then minus the ln of t, ln of 2 times t, which means that getting rid of those minuses, 1 over 20 by the ln of 2 is equal to t. And if you put that into your calculator, you get a time of 0.072 seconds. Okay, so that was that question.